Dear students, let's see this question. Here, a thin circular coin of mass 5 gram and radius 4 by 3 centimeter is initially on a horizontal xy plane. For example, here a coin is there. The coin is like this. Coin is on. It is on xy plane. It is, and radius is given. How much it is? 4 by 3 centimeter. Is initially on a horizontal xy plane. The coin is tossed vertically up by applying an impulse of root pi by 2 into 10 power minus 2 Newton second. So here he applied some impulse. So at a distance of 2 by 3 centimeter from its center. For example, it is center here. From the center at a distance of 2 by 3 centimeter, he applied impulse is there. He applied some impulse here. Impulse. So now what will happen? The coin spins about its diameter and move along the z direction. So already we know generally we are seeing also when we toss a coin. So we will hold one coin and we will apply some impulse, right? So when we apply some impulse, the coin will rotate. Will rotate and it will go up, again it will come down. Clear? So in a similar manner, with respect to this diameter, it is rotating and it is moving up. And is asking that by the time the coin reaches back to its normal position, it completes n rotations. So when I toss, so coin is rotating and moving up, again coming down. So when it is coming to its initial position, it completes n rotations. He is asking that the value of n is. Now we will see how to solve this question, right? Easy only. And this is advanced PYQ. We will see here. He is given that mass is given. First I will write total. I will write here. Mass is given. M is equal to 5 gram. 5 into 10 power minus 3 kg. Mass is given and the radius of the coin is given. Total radius is given. So R is equal to 4 by 3 centimeter. So 4 by 3 into 10 power minus 2 meters. And I will write where the impulse is applied, right? He is saying that at a distance of 2 by 3. This one I am writing small r. This one is small r. So how much small r is given? Small r is equal to 2 by 3 centimeter. 2 by 3 centimeter, which can be written as 2 by 3 into 10 power minus 2 meters. And after that, he applied an impulse. Impulse is how much? Impulse is given as impulse J is equal to pi by 2 under root into 10 power minus 2 Newton second. Now we have to find out how many number of rotations it did. So we have to calculate n value. We have to calculate. So how to approach? So many times I will say to the students, when we are dealing with the rotational mechanics, so we have to go simultaneously. Simultaneously means translational and rotational. We will see here. So first we will see translational. Translational force is applied. So here impulse is there. Impulse is nothing but change in momentum. So impulse is nothing but change in momentum. Mass into velocity. So here impulse is given as pi by 2 under root into 10 power minus 2, which is equal to mass how much? Mass of the coin is 5 into 10 power minus 3 into V. So here it is minus 2 and this one get cancelled. Minus 1 is there. I will write pi by 2 is equal to 5 by 10 into V. 5 by 10. Why? Because here 10 power minus 1 is there, na? 10 power minus 1. So 10 power minus 1 is 1 by 10. So again it will go 2 sir. So directly I will write V is equal to 2 root of pi by 2. I got velocity value. When we applied impulse, the coin will move, the center of mass of the coin will move upward with some velocity 2 root of pi by 2. So we know when a body is projecting upward with the velocity u and it reaches the maximum height and again coming back. So at that instant, if you want to find out the time of flight, what is the formula for time of flight? Time of flight T is equal to 2u by g. So here I will write T is equal to 2u by g. Formula it is, u is nothing but here velocity. So I will write here, this is v, I will write 2v by g. So here 2, v is root of pi by 2 upon g. G is nothing but 10 here. So 1 by 5 into root of pi by 2 seconds. So I got a time. This is about translational, right? Now we'll see rotational. So along rotational, this impulse will produce change in angular momentum, right? So here impulse is nothing but here rotational impulse. Rotational impulse is nothing but linear impulse into its perpendicular distance. So J into R, which is nothing but impulse is given how much it is? Root of pi by 2 into 10 power minus 2. And impulse, where it is applied? The smaller. Where it is applied? The smaller. Smaller distance is 2 by 3 into 10 power minus 2, which is nothing but I omega. Impulse is I omega. Clear? And what is I? Moment of inertia. Moment of inertia of this disk along the diameter. It is not along the perpendicular to the center, it is diameter. So it is similar to here, I will write here pi by 2 into 10 power minus 2 into 2 by 3. And here 10 power minus 2, here 10 power minus 2. I will write directly 10 power minus 4 I will write. So which is equal to I, moment of inertia. Moment of inertia of this disk. Try to understand. The disk is this one. And this one is the moment of inertia. So how to find the moment of inertia of that one? We know by using parallel axis theorem and perpendicular axis theorem we can calculate. So this moment of inertia I is equal to m r square by 4. I is equal to how much? M r square by 4. So I will write here I is equal to m r square by 4 into omega. So again if you want to write here pi by 2 under root into 10 power minus 4 into 2 by 3, which is equal to m already is given 5 into 10 power minus 3 kg. 5 into 10 power 3, 10 power minus 3 upon 4. R square is nothing but the here it is moment of inertia of the disk, whole disk, radius you have to calculate. The radius is given as 4 by 3. 4 by 3 into 10 power minus 2. So here it is 4 by 3 into 10 power minus 2 whole square into omega. So if you solve, you will get a omega value. After that omega, we will try to find out the value of n. Clear? Now here important points are, this T is very important. T and V is important. Again, I want to calculate omega here, this equation. Clear? Just I will erase here and I will try to explain. Right? See this equation, just see this equation. Pi by 2 under root into 2 by 3 into 10 power minus 4, which is equal to 5 by 4 into 10 power minus 3. And again here 4 by 3 whole square. 4 by 3 whole square. 4 by 3 whole square means 16 by 9 into 10 power minus 2 whole square. So 10 power minus 4 into omega. 10 power minus 4 into omega. So here it is 10 power minus 4, 10 power minus 4 it cancel. And 4, 4s are get cancelled, right? So I will write again here, just see. Here it is pi by 2 into 2 by 3, 2 by 3, which is equal to, here it is 5 is remaining and down 9 is remaining here. Again here 10 power minus 3, again 4 is there here, 4 into omega, right? So 5 4s are 20. So I will write directly, here it is 20 by 9. So again we can write here 2 10s are, 3 3s are. So we'll write pi by 2, which is equal to 10 by 3 into 10 power minus 3 omega. 10 power minus 3 omega. From this omega we will calculate. So if I want to calculate omega is equal to pi by 2 into 3 by 10 into, here 10 power minus 3 is there. If it will come here, it is in denominator. It will go in numerator. So it is 10 power 3. This is omega value. Clear? This one is omega value. So try to understand again. So now our target is to find out the number of rotations it did, coin did, right? So we know that theta is equal to omega t. Theta is nothing but angular displacement, right? So we know one complete rotation it is 2 pi. So if n complete rotations are there, so n into 2 pi, which is equal to omega t. So from that, what I'm going to calculate? I'm going to calculate the number of rotations. I will write n is equal to omega t by 2 pi, which is equal to omega already calculated. How much it is? Pi by 2 under root 3 by 10 into 10 power 3 omega, and t already calculated 1 by 5 into pi by 2 upon 2 pi upon 2 pi. So upon 2 pi is nothing but 1 by 2 pi you can write. Clear? So I will write here 1 by 2 pi will write into 1 by 2 pi. Now see, this one is root pi. Root pi into root pi is pi. This pi get cancelled. So I will write this pi get cancelled, right? So again here, we'll see here, this is root 2 and this is root 2. So root 2 into root 2 is nothing but 2. So here n is equal to, in numerator if you see here 3 is there, and 3 into 10 power 3 is there, upon, and denominator, this is root 2 means 2 into 10 into 5 is there, right? Am I clear? So here what we will do? Here we will do 3 into 10 power 3 upon 2 5s are 10, 10 10 100. So 100 is nothing but 10 power 2. This 10 power 2 and this one will go. So here remaining is 3 into 10, which is nothing but 30. So it will make 30 rotations, right? I hope you understood. Thank you.